Hi everyone, in this video I want to talk about graphing shifts and reflections of parent functions. Another title for this is transformations. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, here is the fun question. What is your favorite dinner that you typically eat at home? So on Algebra 2, transformations would fall. Typically this is one of the intro topics of the class, to understand how graphs shift up and down and reflect across an axis. So notice here in geometry you also see transformations, and that is more like shifting or dilating or reflecting a shape, such as a triangle across the coordinate plane. So we'll start with problems like these, and something to remember going forward is we must know what these parent functions are. So think of the word parent as describing like the foundation or the most basic root version of these functions. So to highlight the most common parent functions that you'd see in an algebra class, these 5 are what we talk about in class. And so we have x squared, square root of x, the absolute value of x, x to the third power, and then the cube root of x. So notice that the x squared and x to the third have similar graphs, but we have a parabola. This has symmetry across the y-axis. And then there is no symmetry for the square root of x. It's almost like half of this graph, but to the side. The absolute value of x is a V shape, very similar to this U with the x squared. And if you notice that these graphs are, the numbers match for in the positive direction. So we have 0, 0, 1, 1, 2, 4. Then we have 0, 0, 1, 2 as our points for one of the sides of those symmetric graphs. And then we have the square root function that is, these numbers but backwards from the x squared. And then x cubed and cube root of x, these are, we call them the snakes. This is a snake, upright snake, and then snake on its side. These are also the inverses of each other. So the x's and y's are flipped. So these are the most basic parents of these functions, and all of the other ones stem from, the transformations of these graphs stem from these parents. So think of it like that. So what we need to do is graph negative x to the third power. Okay, so if I have really any function, maybe we'll use absolute value as our example. If we had like y equals 3, absolute value x plus 2, and then say plus 5. This number right here is the horizontal shift. The plus 5 is the one that moves it up and down. That's the vertical shift. And then this number here would indicate a stretch or compression, which I have another video on. So that's a different, set of circumstances. So I separated them. But if this 3 was, say, negative, the negative would indicate a reflection. So that is how you sort of think of all of it coming together. Now, let's say this is the, x squared version of that. Well, it's all the same. So this is the horizontal shift. This is the vertical shift. And, if there was a negative out here, it would be the of that graph. So now let's get into some of the details. If it's x cubed, remember that's that snake like version, but this is the positive x to the third. If we have negative, then that would change all of the y's to be negative. So let's say we have x, y, and if you plug in 0 to just, instead of y, we'll call it x to the third. If you plug in 0, you get 0. If you plug in 1, you get 1. If you plug in 2, you get 8. But if we want to do the opposite of this, meaning negative, that would basically just change all of these to be negative. And we know we don't have a negative 0, so we just keep it 0. So instead of that positive motion going from left to right, it's going to be a downward motion. So it'll be 1. So I'm going over 1 and then negative 1 over to negative 8. And if I plugged in more points there, or just observed that it is symmetric about the origin, the 0, 0, then I would notice that this graph is going this way instead. So see if I graph that well. We'll make sure it's symmetric. So we have, if we have 1, 1 here, we'll do 1, 1 this way, and then 2, 8 this way. Okay. So that is our reflected version of basically this. Positive situation here for the second one. So this is where we have to pay attention to my little notes up here. So negative 4 right here actually tells us you would think it's going to be going to the left 4, but it's actually the right 4. So that's right 4. So we'll say horizontal shift. If it's plus this h, then it will be left h. If it's minus h, it'll be right h units. Vertical shift, if it's plus the k, then it's going up k units. If it's minus k, that is going down k units. That second one is the one that makes sense to me. Like, it's if it's positive, it's going up. If it's negative, it's going down. So it's an interesting thought to think about, why is this here shifting right 4 units? Think about that a little bit. Why is it not going left? All right, so I know that this graph here is going to be my typical x squared graph. We have x, and for y, we have x squared. If I have 0, 0 going in, I'm going to do 1 and 1, 2 and 4. But I need to move this thing. So think about like 0, 0, 1, 1, 2, 4. That is just regular x squared right there. That's just regular x. But I need to shift that graph right 4 and up 2 units. So let's do that. Let's move the vertex and then work on graphing. So I'm going right 4, up 2. So my vertex that was here is now here. And so now I draw my graph. It's like, oh yeah, from there I go up 1, 1, 1, 1, and then 2, 4, 2, 4. So there's our answer here. The practice problems to try are very similar. We have another quadratic, another x squared graph, and this time an absolute value graph. Remember that this will be the u and this will be the v. So try those. See if you can pause the video, try them, and check the answer in a second. Answers are here. So this one is going upwards because it's positive. This one's going downwards because it's negative or reflected. And notice the shift, the number of units in both cases are indicated by these numbers here. So 6 and 2, 1 and 2, but think about in which directions they should go. So, a quote for some motivation: friendship is comfort knowing that even when you feel all alone, you aren't. So, I hope this video helped you in some way. And if you have answers to the fun question, feel free to leave them in the comments. If you'd like to keep up with new videos, you can subscribe. Thank you.